Hi everybody. Welcome to the first of our Esri ArcGIS Data Interoperability extension and ArcGIS uh, Artificial Intelligence and ArcGIS Data Interoperability Skill Booster. Right, I've got to admit that's a bit of a mouthful, and clearly messed it up straight away. So I think henceforth I'm going to refer to the Esri ArcGIS Data Interoperability extension simply as Data Interop. I hope that's okay with everyone. Um, so the intention of this skill booster is to provide essentially a framework for building a basic understanding of the capabilities of the Data Interop tool when it's used in conjunction with third-party and locally running AI services. My name's Simon Green. I'm Principal Technical Specialist at Avineon Tensing, and I'm joined here on the call with my colleague, Siobhan Ryan. We're going to be on hand to answer any questions you've got. And if we don't get to answer your question during the session, we'll follow it up with you after the event. And I think we've also got Oliver Morris lurking in the background, hopefully answering Q&As as well. So Q&A is enabled, and feel free to pop some questions in there. So after I've sort of provided an initial overview of AI and the Data Interop extension, Siobhan's going to take us through some 5 example workflows containing 5 transformers lasting 5 minutes each. So if everything goes to plan, we should be done in about 45 minutes. The other thing you'll see on screen at the moment with me sharing is a Git book. So we've published a link to the material that's covered in this skill booster through Gitbooks, and I'm going to quickly set the scene. But if you want more information and details, please refer to that Git book for further reading and information. Before we begin, just a very brief introduction to who we are at Avineon Tensing. So we're a data consultancy company. We specialize in AI and all things geospatial. We're a partner of Safe Software and also Esri, and we provide professional services, training, coaching, and events and skill boosters such as this. Now, I don't think AI needs much of an introduction. We've all heard of it, and in all likelihood, probably all interacted with it, knowingly or otherwise. And AI encompasses a broad range of capabilities, including things like reasoning, learning, problem solving, understanding language, recognizing patterns, and being creative. And some of the things that help that along and sort of key aspects of AI are things like machine learning, deep learning, natural language processing, computer vision, and generative AI. And it's generative AI that we're going to be focusing really on today. This technology uses large language models to understand and essentially mimic human creativity. And they're trained on insane amounts of data and can perform tasks that can help us day to day, like text and code generation, translation of languages, summarization of documents, and answering questions. Now, the Data Interop tool brings FME form capabilities directly into ArcGIS. And that allows for no-code tools that streamline the extraction, transformation, loading of data across diverse systems and file formats. And the tool is an extension for both ArcGIS Pro and ArcGIS Server. Now, it's going to be ArcGIS Pro that we're going to be focusing on today. So it's a no-code visual programming tool for developing extract, transform, and load workflows. And it's maintained by and licensed through Esri, but it is built on Safe Software's FME data integration and any AI platform. So that means it's capable of reading over 400 different formats, reading and writing, and it contains over 500 transformers to allow you to transform your data. And that also includes access to a further 1,000 custom transformers through the FME hub. And the beauty of the Data Interop tool and having this capability is that you can then call this ETL tool inside of Model Builder and also include it in Python code and workflows too. So in the context of this Skill Booster workshop, we're going to use the Data Interoperability extension to integrate AI services into our geospatial workflows. So the Data extension allows us to connect to a range of AI services to transform and automate our data and processes. But why use the Data Interop to do this? Well, the key to the Data Interop tool is its power to orchestrate and automate. So we can prepare data for submission to AI models. We can feed that prepared data into the AI services and then integrate the AI generated output into our data infrastructure, all in the same workflow from the comfort of a visual programming interface. Now, before we sort of dive headlong into AI with Siobhan, I think we should probably take a bit of a step back and get to know the Data Interop extension. Now, I have pre-recorded a video that I'm going to talk over. So in order to get access to the Interop tool, we can get that through the analysis tab at the top, and there's a little section over on the right called Data Interop, and that gives us access to the Workbench application, the Data Inspector, and the Quick Translator. We've also got some geoprocessing tools there that allow us to get access to quick translation tools to import and export data into and out of the Esri ecosystem. We can also get access to the tool through the Start menu. I've pre-connected to a training data folder, so we're going to read some data in from a format and export it out, and we're going to do that with the spatial ETL tool. So we're going to give it a name, we're going to give it a label which describes it, and it will be the name of the tool in the toolbox, and a description to give us an overview of what we're going to do. So essentially, we're going to be reading data from an Excel spreadsheet and writing it out to a file database, file geodatabase. So running the tool and opening the tool, it opens up the Data Interoperability extension and presents us with a workspace, generate workspace dialog. And that allows us to configure the data sources that we're reading and writing. So we're going to be reading from an Excel spreadsheet, and they're going to be music venues from London. And we can grab that data from our local drive. And all this data is going to be available afterwards through the training manual and the data package. And we're just checking here that all the data is as we would expect. It's geocoded, so we're going to have a spatial element to this data. We then want to set the coordinate system to WGS84 because the coordinates are in lat long, which is good. And then we configure the writer. So this is going to be Esri file geodatabase. Find a location for that to write to. So the training data output folder, call it cultural data, and then hit create. And then again, we just want to check the parameters to control the way the data is written out. Every time we run this workspace, we might want to overwrite it, so we can check that box and click OK. So clicking OK here will generate a very simple workspace that essentially has a reader feature type on the left and a writer feature type on the right, and that allows us to essentially do a translation. Now, we want to do a bit more than that. We want to have a look at the attributes. We want to maybe remove some attributes that are potentially not relevant. So some ward code and ward name information. And I might want to rename an attribute to make it a bit more context sensitive. So I can right click and replace that link with the attribute manager, which is a really handy transformer that allows me to interact with my attributes, adding, removing, spelling venue wrong, which is always fun, and removing some attributes that I don't want. We can also create attributes in here and set attribute values. Okay, so we're just doing a really simple restructuring of our data here. And we can run this in data caching mode that allows us to see the data at each stage in the translation. And we can see that the attributes are updated automatically on the writer feature type. And in the visual preview, the data preview, we get a table of data at the bottom and also a map representation of that data. Now I might want to filter off some data based on some QA that I want to do, specifically around the OS UPRN value. So that's a unique property reference number. Now I know that some of my UPRNs in the data don't have a value. So I want to make sure that all the data that passes the test has got some kind of value for that. I also know there are a lot of UPRNs in there with a value of 0. So I want to make sure that the values that pass this test do not have or are not equal to a value of 0. So combining that two test clauses together, I should be able to filter out the data, keep what I want, and throw away the data that doesn't meet my expectations. And again, you've got the feature caches there that you can click on to see that data if you want to. The final thing that I'm going to do is just tidy up the writer feature type here and rename that. So I want to rename, remove the no geometry prefix, suffix rather, and then come in here and make sure that I'm actually writing out a geometry instead of just a table of data, which it's currently configured for. So I'm going to set the geometry type to GeoDB point. So when that feature class is created, I will have a point data set. So, you know, I'm keeping this nice and simple just to give you guys a bit of an insight into this. So I'm going to save that workspace, come out of the Data Interop tool and return to ArcGIS Pro, save my project, and then I can look at running and opening that application that I've created. So this gives me a user interface where I can choose my source and destination if I wanted to change that. And then I've got a few options on the run. So I can schedule it if I want to, super useful. I can run that on demand, and I can also copy the Python and use that in some existing code if I wanted to include it in some kind of orchestration. So I'm running that workspace. That's basically reading the data, passing it through the transformation, and writing it out. Get a log file at the end. There's a warning there about my locale settings, which is actually a known bug in 25.1. So I'm now going to look at that data that I've generated. So I'm going to refresh the folder on the output, look at the cultural data, and then just drag those music venues straight into my application window. Clicking on them, you get the incorrect spelling of venue name there, so that's proved that that's worked. And you've got the OS address space there. Okay, so you know that was a real sort of whistle-stop tour of ArcGIS Data Interop tool. What I will do now is stop sharing my screen and hand over now to Siobhan, who is going to be talking to you about her 5 examples around AI and how the Data Interop can make use of AI services. So over to you, Siobhan.
Perfect. Thank you so much, Simon. That really set the scene quite well. And I even learned something there about the right-clicking with the attribute manager. So we're all learning something today. Cool. So to get started, just to set the scene for what I'll be going through with you guys, we'll be going through 5 workspaces, hopefully within 5 minutes each, to kind of showcase 5 examples of utilizing AI within the Data Interop tool. The first 2 we'll be looking at some tassel data and looking at how we can clean that data and then also enrich that with Google Gemini as well as OpenAI. The third example will take things multimodal with some pictures of some squirrels. And then our 4th example, we'll look at how we can extract and geocode some text from a PDF. And then finally, we'll look at some sentiment analysis in our final example, comparing a local versus a cloud AI service. So to kick things off, our first example, we're looking at cleaning and standardizing a data set of tassel data. So the data is coming in from Overture Maps. If you're unfamiliar with Overture Maps, it's an open data set online. It has worldwide global coverage of geospatial data covering places, points of interest, transportation routes boundaries. Really useful data set. Recommend you check it out. There's also a great blog article by Bruce Harold on the Esri community and the ETL patterns around how you can utilize the cloud native data from here inside ArcGIS. To jump straight into our workspace, I've got this nice and simple workspace here where I'm first reading in our overture maps data of castles. So if we quick look at the SQL query here, we can see we are creating this Partey file from an S3 bucket from overture maps. And we're selecting castles, so the category is castle, and we've also set a bounding box here. So we're trying to find castles within a bounding box around the Welsh and England border in the UK. So if we don't out of there, I'm just going to run the rest of this workspace. And the second transformer here, we've got a vertex creator. So from our SQL query, we've got a long and a lat. So I'm using those and setting the coordinate system here so that I can now view them on a map, and we can see its respect to that bounding box we gave it in that SQL query. Next, we're going to send off this data to our OpenAI ChatGPT connector. And in here, all we're asking it to do is to standardize our addresses and our phone numbers. So we want to correct any phone numbers that might have not got the +44 on the front of it, and also we want a standardized format of our addresses. It's quite a common problem for us to kind of be given a bunch of data and it's all in different forms and formats, and so instead of having to use like a regex expression, we can use AI to simplify and kind of automate that process for us. Finally, from there, we're using a JSON extractor here, so we're going to use a JSON extractor to get our 4 attributes from our response from the AI. So we've got our phone numbers and addresses, and then what kind of change is made to those. So if it's an invalid phone number, if it's cleaned or tidied this value in something, let us know.
So
finally,
Siobhan, sorry, just to interrupt there. So you're specifically asking ChatGPT to bring you back a JSON response.
Yeah.
Is that so that you can standardize the output to consume it easily inside a tool like this? Because
exactly.
Because historically, right, you sort of ask ChatGPT or an AI service a question, and you can get quite a unstructured response. So we're essentially using the AI to give us structure and predictability, so that we can then consume it inside of the data interop tool.
Yeah, exactly. It's almost like JSON's the language of the AI model. So if we asked it to give us back a JSON response, then we can structure, and we know that they'll have that structure in the response so that we can then standardize the rest of our processes. In this example, we've got 47 castles, but you might have 400,000 of a data set and you want to run it all through an AI model. You don't want to have to be guessing what the response is going to be every time to extract that data.
Yeah, that's super useful.
Really useful.
Super powerful. Yeah. Cool. Sorry to disturb you.
No worries. Jump in whenever.
Yeah.
And finally, here we've got a test filter. So I'm just filtering out addresses from the castles that were invalid, or if there's an invalid phone number, that you might want to have a human in the loop kind of process where you would manually review those data set, those what's the castles to create those. Meanwhile, those that passed our test, those can be written off to our file geo database here. So a nice and tidy standardized addresses and phone numbers can be written out. Cool. So that's our first one, just looking at how we can clean and standardize our data sets with AI. Quite simple and also quite powerful and time-saving. I'm going to jump straight into the second workspace now, which looks at the same data set. So now we're reading in the cleaned castles data from our file geo database. So we've got our corrected addresses in here, and this time I want to augment and enrich my data. So I now have my standardized data, but I want a bit of extra information. So this time we're going to Google Gemini. I'm running the Gemini 2 models today. You might have seen recently the 3 models came out, but they're currently being slammed by everyone trying to use them and test them. So we're using the 2 models, but definitely they're all pretty good at what they do. And in this prompt here, I'm asking Google Gemini to return some information for me on the tassels. So I want to know how old the tassel is, and I also want a Wikipedia page with information about my tassel. But if it's not a castle, also I'd want to know. So maybe we'll see. But some of them might not be tassels, so we'd like to know it's not a historic tassel. From there, I'm going to extract that JSON again. You'll see it's quite a common pattern. We're extracting the JSON after the AI prompt. And here we're asking for the tassel age, a Wikipedia page, and also that error message if it wasn't a tassel. This
Right.
test filter here.
Siobhan, sorry. Again, sorry to interrupt. So you're asking the AI for a web page, right?
Yes.
How is that happening? Because historically, when you've asked for web pages or URLs to resources, AI's completely hallucinated and giving you absolute garbage. So what's changed? What's changed?
Cool. So, yes, so there's a functionality or tool within Google Gemini called grounding Google Search. They also have it with Google Maps as well, so the Google Maps API. So with the grounding with Google Search, it goes off to Google Live and pulls back information from a Google search. And so it's able to get live information. So even things like the current weather conditions in places or like live information, it can pull back. And then also is less likely to hallucinate on those responses to you as well. So quite a powerful tool to be able to enable within your requests.
That's mental because, you know, each model has got like a knowledge cutoff date, and now it's able to expand out of that knowledge to then go to the internet to enrich it even further. Yeah, that's fascinating.
Yeah, really cool. Yeah, so in our test filter here, we just want to filter off things that aren't castles, and we can see here it's filtered off these two. They're called M&M entertainments. So maybe not a historic castle, but it came up in our overture query because it's a place you'd hire bouncy castles from. So here we've just been able to filter off those two castles and not add them to our final data set. Then we've got a sorter here. So a sorter is just going to change the order of our data. So we just want to filter, sort here by the age of the tassel. So we can see after doing this, the first tassel in here was built in 213 and the most recent one in 1875 in Cardiff. Finally, like Simon mentioned at the start, got an attribute manager here. We just want to remove some attributes and rename some so that they're nice and standardized for our final writing out to our geodatabase. And then that's it. So if we go back to ArcGIS Pro now, we can refresh this one and our castles are added to our map. And if we zoom to layer, we should see our castles that cover Wales and England. And I guess maybe not in 10 transformers, we've been able to clean and standardize and also enrich our data of castles, and we can kind of scale this process to beyond 47 castles, but hundreds of castles across the country if we wanted to.
Yeah, so it's scalable. That's great. That's great. Cool. Where are we going from castles?
Okay, I think we're going to my favorite one next, which might be biased because I get really excited by squirrels because in New Zealand we don't have them. But we're looking at some pictures of some squirrels in our next example. So we'll take things multimodal and looking at classifying images of squirrels. Previously, we've done some work with Wildlife Trust up north, and they've developed a model that was able to detect grey and red squirrels. So we've got a data set here taken of that has already identified the species. But from that, we also want to now identify the location that they were taken in. So we can see in this nice dashboard, we've got photos, quite cute. They're in a range of different locations, and we want to identify and classify those. If we jump into this workspace, this time I'm not reading in from a dataset on my local computer. I'm reading in from ArcGIS Online. So in this reader here, I'm going to read in from ArcGIS Online from that feature service. I'm then going to expose an attribute here for the attachment ID. So that I've read in my layer, but also want to be able to read in my images that are in each point. With my attachment ID and my object ID from my data set, I can then use the image fetcher to read in those images. So here I've got my AGOL URL, and then I've got my object ID from my layer, as well as my attachment ID from that particular point. We can see here we've read in our images, and those images are what is going to be sent to Google Gemini this time to classify our pictures. And a really simple prompt in this one, all we're doing is saying classify the type of location this drill is found in, and provide it back to us in a string. Press run. The JSON extractor again is going to look at that, extract that location for us, and write it out to our location field here. And then finally, with our writer, this time I'm using an update feature operation. So typically you'd probably see something called an insert operation. You're just adding data to the bottom of a table. In this case, I don't want to be overriding my entire table. I want to be updating that particular location column. So by using the update, it will update only the location field where it matches that object ID. And if I go back now into AGOL, if I refresh this, we should hopefully have our locations for each of our squirrels. Refresh that too. And we can see locations are found in grasslands. This one's on a deck. Outdoors, so yards. So it's a range of locations that's been able to classify without much instruction from us at all. Obviously, nice. This is a fairly simple case, but you might have other scenarios from surveys where you've got hazard detection, you're trying to classify some damages, you're doing utility surveys. So there's lots of use cases for the survey kind of method of classifying and looking at the data from that ArcGIS Online. It's quite powerful.
I think also just worth pointing out here that the prompt is the key to this. And you know, there's lots of resources out there to help you engineer prompts, and also more commonly sort of context engineering as well. And you know, just the terminology that's being used in that location, like deck and yard and backyard, is, you know, it's not necessarily sort of British English, if you like. So you could engineer the prompt to sort of force it to use like the UK sort of nuances for those types of locations, if you wanted to.
I think it would be a great case for an enumerator. So you have a classification kind of, you have like 5 options for it to pick from, rather than coming up with its own name for a forest or a grassland.
Yes,
you have an enumerator, so it can pick from a list of options.
Yeah, so you get consistent spelling of grassland, for example, so you don't get a lowercase G and an uppercase G. So yeah, no, that's a good idea. Yeah.
Cool. Unfortunately, our next example might not be as cute and furry as squirrels, but we'll take things maybe a bit more geospatial this time, with trying to extract unstructured data and addresses from a PDF. So we've got a PDF here from the City of London, and it's got a range of addresses that can be found within it. A range of formats. There's one here. There's some in these lists, all in different forms, and then we want to try and pull out those addresses and geocode them. Cool. So in this example here, we're reading in a PDF as a text string. So if we look at this, it comes into this text string, it's all over the place. We've got a S, comma, half words, half sentences in different formats. So what we're going to first do is use the aggregator here to smush all of those lines into a single text string line for us to send to our AI service. So then we have our full PDF of text with our addresses in it. So on this Google Gemini connector here, we're sending off that text string and asking it to find the addresses for us, providing it, like Simon said, a lot more instruction around how we want that data returned in that prompt. We're also here using a structured output. So the structured output then defines that JSON schema that the AI responds with. So instead of a JSON object like we've had in the previous examples, in this case we'll be using an array. So we're sending one piece of text in, but we are wanting 40, maybe 50 addresses to be returned to us. So we're asking for an array that we can then fragment in our next transformer. That's what we're doing here. JSON fragmenter, instead of extracting that one, it's breaking up every address that the AI has responded to us with into its own feature. So we've got a list of addresses here. Next, we've got a geocoder. So we're using that ArcGIS Online geocoding service here. We're passing in that response and we're getting back our geocoded addresses. So that we can see here on a map, we've got now addresses and points for our polling locations. Finally, again, the attribute manager, just to remove the attributes we don't want and to rename and standardize how those are written. And again, we're running out to a file geodatabase that we can see on a map. So if we refresh this one, just load. PDF extracted text. If we go over across to London, we've got our points predominantly all around the City of London, so it looks like it's done a pretty good job. We've got a couple out in the WAPs. So this one's North London, so maybe not the City of London, but we can see here the AI location was 68 Long Lane, so maybe there's a long lane in multiple locations in London.
It's a long lane, so it stretches from the City of London all the way up to Finchley, right?
Who knows?
Yeah.
Perfect. Okay, cool. So yeah, not just images, not just text that can extract information from your PDFs if you want to. If you have location information or other information locked within old PDFs, maybe planning documents, historical records, AI and FME, AI and Data Interop tool can be quite powerful in kind of unlocking that and structuring that data for you.
And it doesn't have to be like a like we're extracting that, reading that in as text items. It could be a rasterized scan of text, and you know, AI is really good at doing OCR type things and extracting that text out for you. So it, you know, basically, if it's been locked away in a PDF, there's a fair chance we can get to it with AI using the Data Interop tool to maybe prep it first.
Cool. Perfect. All right, on to our last one. We seem to be making good time, so if you guys have any questions, please pop them in the chat and we can hopefully get to them. But our last one's looking at some survey 1, 2, 3 feedback. So we've got a survey form here and we're asking people to provide a rating of a widget and give a star review. So that's I guess a subjective and quite a quantifiable 1 out of 5 or 2 out of 5 response. We also want some free text comments in there as well, so for them to give some comments and some commentary on what we can do to improve our new widget. So in this example, we'll be looking at comparing 2 models, so looking at a local large language model through an Olama connector, and then also a cloud model, so using Google Gemini again. Jumping into this one, if we look at the translation log, so I previously have run the local AI model and finished that off. I'm just sending that same data through to Google Gemini. But just to compare, one thing before we start is the time. So the translation log here has how long that session took to run. So it took a minute, almost a minute and a half for the local model to run. If we run it now on Google Gemini, we run to this one, just to compare the time. So there's obviously trade-offs when you pick your AI service you want to be using, whether that's local or whether that's a cloud service like Google Gemini, Claude, OpenAI. There's lots of different ones out there, and they all have their strengths and weaknesses. With Google, obviously, or a cloud service, you're sending data off, so there could be security of confidential information, those kind of concerns you have, versus a local model where things are kept private and all on your own computer, so nothing's going out to the cloud. But then obviously you look at things like time and speed. The Google Gemini did the same transformation in 8 seconds. So you've got some trade-offs to make.
Yeah, I think also with the local generative AI, it's going to be dependent on the equipment you're running that model on, whether it's enabled for GPU capability and stuff like that. You've got to remember that Google Gemini has got almost an infinite amount of resource allocated to it. So, you're running this on your local laptop with a modest spec, admittedly. So, it's your mileage is going to vary with your local generative AI caller. But
exactly.
you could have it installed on a server, and that could be a high spec. And again, we're basically interacting with that local generative AI through the API as well. So it doesn't have to sit on the same machine as where the data interop tool is, for example. It could be on a server in your network somewhere if you wanted it to.
Yeah, exactly. And look at the accuracy of the models as well. That obviously, if you're doing something locally, you're likely to have a much smaller model available to you compared to the OpenAI, Google Gemini models, which are much larger, huge models, so trained on a lot more data.
Yeah.
So just to make some comparisons around the responses, most of them are fairly good. If you look at this one, where are you? User 10. This is my favorite one. This person here in their feedback has given some quite sarcastic comments. Things like, I suppose having a predictable, boring workflow where buttons actually do what they say was just too much to ask for. Just a stellar performance all around. So quite a sarcastic response. If we look at what our AI response here is, the user rating gave a 5, which obviously, again, sarcastic for the comments. And here, our local model said the store matches a positive sentiment. If we look at the same example in Google for user 10, Google Gemini was able to pick up on that highly sarcastic comment. And so it has that nuance in there that maybe the local model for the smaller size isn't able to pick up on.
Yeah, exactly. And, if you downloaded I think, is it Qwen 3 you're using there? If you're, that's probably a reasonably lightweight model, maybe a couple of gig, something like that. So that's only got, probably a couple of billion parameters in it. So all the data that it's been trained on. So larger the model, the more nuance you're probably going to be able to get from a local generative AI. But yeah, it is quite remarkable how it can pick up on that. And the other examples in there, it's not just English. We've got other languages in there, and it's able to understand those languages and work out whether the score should match the sentiment that is derived from the text field. So
it's been able to understand the Chinese response, and the store of 1 didn't reflect the comments, so it's upgraded that store for us. So it's quite impressive. But obviously, I guess the great thing about FME and ArcGIS, Interop tool and all of this is that you're able to choose. So some cases you might want the local model, some cases you might want Google Gemini, other cases you might want Claude or OpenAI, and it's all about that trade-off and kind of working out what's the best model for the job.
Yeah. Or using a combination of those in the same workspace as well, right? So you use the strengths of each of the models that you need. So, you might be using some kind of object detection service to extract out the bounding extent of something, to then pass that section of the image to another AI to make sense of it. So yeah, it's that sort of orchestration and flexibility that the data interop brings to you. Yeah, great. Well done. Thanks.
Cool. Just to wrap things up now, there's some information in the step book around how you can set up API keys. There's some information on OpenAI and Google Gemini, as well as if you're interested in Olama and running things locally, how you can download that and get started. But just to wrap things up, there's some information here. I think, Simon, you know a bit more about this.
Yeah. So we've sort of trawled the internet to find some additional resources that you might find useful. So specifically around the data interop tool, whether you might want to start looking at integrating that into ArcGIS Server, some pro documentation, and some additional learning resources there as well, and the ArcGIS Data Interop community there. Some of these transformers that we have been using, so specifically the Google Gemini Vision connector, is a custom transformer that's been created by us at Avineon Tensing. So we're a verified publisher, which means that we have a responsibility when we publish these transformers to the community that they satisfy SAFE's requirements, and they're essentially production ready, and we have to support them. So there are a handful of verified publishers out there on the FME hub, and we're proud to be one of those. And also, moving on into next year, I know Christmas hasn't quite arrived yet, but if you are at a loose end towards the end of January, we're running 3 FME UK tour events: Leeds, London, and Bristol. They run from the afternoon, from 1 o'clock till about 5:30. So they'll be very much focused on user stories. So if you just scroll down a little bit there, Siobhan, we're going to be joined by a huge number of organisations that are very proud to be sharing their experiences with automation and ETL and AI. And we've got some really good speakers lined up, including some guys from Esri there as well. So if you wanted to join us there, we'd love to have you. And we'll be having a bit of a social and networking session afterwards as well. So the link to register, I think probably, if it's not there already, will be in the Q&A very shortly. And then just finally, we've got some ArcGIS Data Interoperability extension training. And we'd like a little bit of a feedback from you guys and what you potentially might be interested in seeing on this. So a poll has just been put out by Oliver. So we're thinking about doing an introduction and an advanced course in data interoperability, and then specifically using AI in the data interoperability tool as well. So we've got a whole load of courses lined up, and it'd be nice to understand what the user community might be interested in doing. And then finally, always good to get some feedback on the Skill Booster sessions that we do. So feel free to feedback. Let us know what worked, what didn't work, what you might like to see in future Skill Boosters. We'd be happy to hear from you on that. And yeah, that just leaves us to say thank you very much for sparing us 45 minutes. I think we're a minute under, so hopefully, but that's all gone remarkably well, particularly live demos. I didn't trust myself, Siobhan, so well done for doing the 5x5x5. And yeah, we're going to stay online for a few questions if anyone has them. Again, if you have to leave and you've asked a question, just say, can you follow up? And we will follow up with any unanswered questions after the event. So we shall let you get back to the rest of your day. Have a wonderful time over the Christmas period. Relax and enjoy, and hopefully we'll see you again in the new year. Thank you very much.